Hello and welcome to today's session. Uh, Only one person has joined so far, so let's wait for 5 minutes and see if others join, and then we'll start today's session. It's 5 minutes now, so I think we should start today's session. I hope I'm audible and my screen is visible to all of you. If any one of you can just indicate that I'm audible and you can see my screen, just type in the chat box and let me know. Okay. Okay, I think I'm audible and visible to everyone, so I'll start today's session then. So, welcome to week 5 of live session for the subject strategies for sustainable design. This week, you would have covered three lectures that are environmental impact assessment and then part A and B for life cycle analysis. So in environmental impact assessment, you would have studied what EIA is, why it is used, what are its benefits, and how it can help you anticipate the impacts that any project or any development activity is going to have over the environment, why it is essential to take into account various impacts of the project or any other development activity, and how you can do a proper impact assessment to ensure that the ill effects or negative effects of associated with any project or any developmental activity is minimum, and the positives coming out of any development activity or project can be maximized. Then life cycle analysis part A and B would have taught you what life cycle analysis is, how it is used to conduct life cycle analysis for different products and different materials that we use in our day-to-day lives, how and the embodied carbon or embodied emissions are associated with different materials, and how uh, processes related to the product's life cycle, like its use, the recycling and reuse, everything, how it involves uh, emissions, and how different parts of a product's life cycle affects emissions throughout the product's life. You would also have seen several examples of day-to-day products which you use every day, how their life cycle can be analyzed, and so on. So I'll go on with the questions which were assigned in previous run of this week's uh, lectures. So I'll just go over the questions. I know that this week you've been assigned a subjective type question and you do not have any objective type questions. But in the previous run of this assignment or these lectures, week 5 had the following objective type questions. So I'll discuss these questions for you. Even though this time you are assigned a subjective questions, these all the material which I'll be discussing, it will give you a background uh, to what you are assigned in this week also, and it can also help you to know the approach of solving questions which you might come across later in your exams. So I'll just go on with solving the questions. So let's start with first question. So first question for today is which of the following is an input for a life cycle analysis for a product? And we are given four options: solid waste, energy, co-products, and atmospheric emissions. So as we studied, life cycle analysis of any product or any material is associated with three components. First is the system boundary of the products, which involves things like acquisition of raw material for the product, then manufacturing of the product using the raw materials. Then we come to the use of the product, which can be uh, further categorized into reuse of the product in some way and maintaining the product over the period of its use. And then after the period of the product's use ends, then we come down to recycling or managing the waste, which comes at the end of the product life cycle. So this is what is the system boundary of the product. Within it, we have to put some inputs, and at the end of its life cycle, we get some outputs from that product. So input, like here within the product boundary, we have raw material acquisition. So we need some raw materials while while manufacturing the product. So at the beginning of the product life cycle, we sometimes also need some raw materials during the manufacturing stage and sometimes even during the product use. So these are the raw materials which you need uh, for uh, the product life or throughout the life cycle of any product. Apart from that, energy can be considered one raw material also, but if you consider physical raw material separately and the energy required in producing any product or any material, that can, if you consider energy separately, then you can consider energy as another input. So inputs, we have raw material and energy, and then in output we can have several different things. For example, atmospheric emissions. So these can be uh, the atmospheric emission as an output can be during the process of raw material acquisition also. So during the process of mining or harvesting, if you're taking the raw material from bio, like if you're taking biological material as a raw material, then even the process of harvesting or forestry can be a part of raw material acquisition. So there are some atmospheric emissions which are associated to raw material acquisition as well. So even the process of harvesting or mining or forestry, they also create some atmospheric emission. Then the process of manufacturing the product also is associated with atmospheric emissions. And then during the use or maintenance or even the reuse of that product, some outputs in the form of atmospheric emission would be there, and same will be there during recycle or waste management of any product. Same is true for waterborne waste. So it depends on which kind of product we are talking. There might or might not be some waterborne waste which is there during the raw material acquisition stage. There can be some waterborne waste during the manufacturing stage. There can even be waterborne waste during the use stage or even during the recycling or waste management stage. Then there can be solid waste. So solid waste can be there at the during the material acquisition time. So while mining gives you the raw material or the raw material which you need for the product manufacturing, it also gives a lot of waste which is generated as the part of which is a part of the natural ore or natural material which you extract from nature, but it is not used in the manufacturing process. Then during manufacturing also there are materials which are not used or they come as a waste from the manufacturing process. Same is during the use process and the recycling process also. So solid waste is another thing which comes as an output. And there are co-products. So co-products are something that are generated as part of manufacturing of some material or even during raw material extraction, but it's not the main product. For example, when you harvest food grains, so you get the grains or the edible crop which we have for human consumption. But as a co-product of that, you also get hay. So hay is not the main product which we are growing the crop for, but we get hay for for consumption by animals as a co-product of that material or that product manufacturing. So that is one example of co-product. So as an output of output from life cycle of any product, you get other co-products also. Not true for all the products, but in some cases you may get co-products. and then some other releases also might be possible. So this is what the life cycle system of any product is like. So this is another visual. So for example, in input energy resources, you might have electricity as energy resource, or crude oil, or natural gas. So for electricity also there can be several sources. For example, if your electricity is coming from a coal powered electricity power plant, so even before you are using that electricity, you can even go further back to how that electricity is being produced. So coal is your raw material there. It might even be hydroelectricity, or solar electricity. So there can be several ways from where you are getting the electricity also. Then other things like crude oil or natural gas is also there. Then there can be mineral resources. So for mineral resources, there can be crude oil, or even ores of metals. For example, iron ore, which is used in manufacturing a lot of equipment or even electronics. Then uh, renewable, it can also be renewable resources. For example, wood or water, or other renewable resources which are available. Uh, then these are the life cycle stages. So raw material extraction, then raw material manufacturing, then product manufacturing. So how these two are different, as I said, that raw material, like you are using electricity as a raw material in your process, but even the electricity has been manufactured somewhere else. So you are using electricity for product manufacturing, but even electricity was manufactured by another entity using some other raw material, for example, coal. So that is another way which you can even think about the manufacturing stage one step further. So there is raw material extraction, from that there is raw material manufacturing, and then from raw material manufacturing comes product manufacturing, which is then transported or distributed for use by the end user. And then after that use, there is disposal and recycling. As an output of various stages of the life cycle of the product, you get emissions into the air. So there can be CO2, uh, SO2, or other oxides of sulfur, then other NO2 or other oxides of nitrogen. And then there are effluents which are released into the water, which affect the biological oxygen demand, which is BOD, or chemical oxygen demand of the water. And then some end products which are released into the soil also. So it can be polluted sludge, or even solid waste which is released into the soil. So when we calculate the environmental impact that any product has, we see what input goes into the production and manufacturing, and then transportation and use and recycling of that product. And we see what all input that is going into the system, what that input is having an impact on the environment. And then we also see what output the system is generating, and what impact that output is having on the environment. And if we see the total impact from both the input and the output, then we can clearly see what an impact the whole life cycle of that product is having on the environment. So this basically what is life cycle analysis, or different stages of life cycle analysis, or you can say the system boundary of a life cycle analysis, or a product life cycle, and the various input and output which go into the system and come out of the system. So what the question here is asking is that which of the following is an input for a life cycle analysis for the product, and your options are solid waste. So you can see clearly solid waste is an output, not an input. Energy, so you see energy is an input, so this is your correct answer. You can even see other options. For example, co-products is an output, so it won't be the correct answer. And then atmospheric emissions are also considered output. So even atmospheric emission is not the correct answer. So the correct answer for this question is energy. I hope this question is clear. We'll move on to the next question. So the next question is, which of the following is not a type of life cycle within LCA? So LCA is life cycle assessment, and you are given four options: cradle to cradle to gate, cradle to site, gate to site, and cradle to grave. So first let's see what are the different phases in any product's life cycle, or what stages we consider for life cycle assessment. So first is raw material extraction, as we discussed just now. So the raw material extraction, which we are extracting raw material from which are present in our earth. So that extraction, the point of extraction or the phase of extraction of raw material, that is called the cradle. So here in the options wherever it's mentioned cradle, so this is what it is meant by the cradle. So raw material extraction in the phase of product life cycle is known as the cradle. Then it comes, we have gotten the raw materials, we have extracted it, then we move on to processing the material. So we are processing it, we are manufacturing, we are processing the raw material, then we are using the output from that processing, and we are using it for manufacturing some product out of it. So all of that processing, manufacturing and processing is the next stage. Then comes transporting or distributing the product to the end user. That is the next stage of the product life cycles. So after we have distributed the product, it ends up in the end user's hand, and then or in the retail where it is sold to the end user. Then the product is sold and used by the end user, and then it then goes on to waste when the end user discards the product, or to recycling if the product is discarded and parts of it or the whole product is then taken for recycling, out of which raw materials can be extracted, which can be further used for processing. So this is the closed loop product life cycle or such. So the waste recycling is known as the grave. So here where it's mentioned grave, so waste recycling or the end of the product use after it has been used by the end user, that is known as the grave. Uh, what the other two items here are site and gate. So this is what is meant gate. So gate means the gate of the factory where the product is being manufactured or produced. So and then is the site. So site is then from the factory the product has to be taken to somewhere where the end user will use the product. So it has been taken from the gate of the factory to the site. So now you understand all the four terms. Cradle is the place of raw material extraction, or the phase of raw material extraction where the raw material for the product manufacturing is extracted. uh, Gate is the factory gate. So it represents the phase of product life cycle when the product has been manufactured but it has not still left the gate of the factory. And site means the product has been manufactured and it has left the factory gate and it has reached to where it is to be distributed to the end user. And grave means it is that phase of the product where the product has been used and now it is no more of any use to the end user, and it is now either the waste will be processed or uh, and the product will be recycled for further use. Okay, so now let's see the different terms. So first is cradle to grave. So it describes the journey of the product, the whole the whole life cycle journey of the product. So from cradle, from where the material have been extracted, to then the manufacturing, then distribution or transport of the material, to then uh, used by the end user and or distribution through retail, and then the grave, that is either waste processing or recycling. So that is what is meant by cradle to grave. Then cradle to gate. So cradle to gate assessment is for assessment which is the product has the raw material for the product has been acquired or it has been procured, and then the raw material is taken for product manufacturing and the product has been manufactured. So this takes into account all the emissions or embodied energy or embodied emissions that are associated with manufacturing of any product till the time it leaves the gate. So that is what is cradle to gate. The life cycle phase or assessment model, that is cradle to gate, it takes off the emission associated to that only. So many a times you might have heard about the term corporate social responsibility. So what they do is they take care of uh, while they calculate their CSR, they many a times the businesses or the companies who are manufacturing a product, they only take care of the cradle to gate emissions. So only the emissions or embodied emissions which are taken into account, uh, which are there in the production of the product. They do not take into account the whole life cycle of the product. So this is what a cradle to gate signifies. And then cradle to cradle is another variation. So it is similar to cradle to grave. I'm so sorry. But what it means that although a cradle, uh, a grave of one product can be considered as a cradle to another product. So cradle is raw material and grave is end product. So one end product for one end user is uh, waste now, but that waste can be recycled or reused or refurbished in some way that it can be used by used to create another product, or it can be recycled, either the parts of the material or even the components or raw materials can be extracted from the uh, waste or after the end of the life cycle of that product. So in that way, cradle to cradle model is formed where the product is being recycled and the end product of another product is being used as raw material for another product. So that is what cradle to cradle is. One thing which this image misses is two things actually: cradle to site. So cradle to site will be from cradle is raw material extraction, and then site will be when the transportation or distribution is finished. So that is there. So now you know what are all the correct types of life cycle assessment models. So you know that cradle to gate is correct. So cradle to gate again is life cycle assessment from raw material extraction, then till the time the product is manufactured but is still within the gates of the factory. Cradle to site is from raw material extraction to the time when uh, the end product has been transported to either for retail or to be distributed to the end user. And cradle to grave is the whole life cycle of the product till the time the product is either a waste or it's available for recycling. So the gate to site is the only one which is not a type of life cycle which we know of. So that is the incorrect one. I hope this question is also clear to you. Moving on to the next one. If you have any doubts, please feel free to type your doubts in the chat box. I'll get to them at the end of the session. So during any question, if you have any doubt, please feel free to ask. Okay. So moving on to the third question. Third question is, as per the report of Procter and Gamble, 2008, what percentage of energy is consumed during laundry life cycle of the in in use phase? So Procter and Gamble did this study for energy demand or carbon consumption throughout the life cycle of a laundry cycle. So they did the study starting from the supplier to transport, then to manufacturing, then packaging, then use, and then disposal. So in this, they found out that the most energy that is being used, or the most carbon consumption, that is taking place during the use phase. So this is what this study is what this question is referring to, and you can see from this graphic that the energy which is consumed during the life cycle of the laundry is 75% of the all the energy that is consumed during the entire life cycle of uh, during the entire laundry life cycle. So that is the correct answer to this. I could not actually, I wanted to refer you to the original study so that you can get a better idea of how this energy consumption and demand have been calculated for this question. So I could not find this exact study for you, but I found another study uh, which is done by another academic. So this is for energy uses from life cycle perspective for different products. So you can see it is there for bathroom tissue, then paper towels, laundry, liquid dishwash, and several other things. So I have provided you the link here, and you can even see it shows you the energy consumption during the material extraction, then manufacturing. So this again is a study for PNG only. So during the manufacturing, then for packaging, then during the use, then transportation, uh, and disposal, everything. So if you want, I could not find the study which is referred in the question, but you can go ahead and refer to this study if you want to see more about how these calculations have been done and how they've calculated the different energy usage uh, for different products in different stages of their life cycle. I hope that helps. Okay, coming back to our presentation, or to the question. So I hope this question is clear to you. uh, So the answer to this question is 75%. So the energy used during the in-use phase of the laundry life cycle is 75%. Moving on to the next question. So the next question asks, which product out of the following is the best example of cradle to cradle recycled material? So again, as we just saw earlier, that the products which can be recycled after the uh, life cycle or the use of the product has ended for one product type or one user, it can still be recycled, and it can act as raw material for another product, which is the recycling process. So the question here asks that which of the following four is the best example for cradle to cradle. So cradle to cradle is a variation of cradle to grave, but it exchanges the waste stage with the recycling or upcycling process. This you already know. So it is actually an approach which is used in design of a lot of products and systems, and it is actually based on mimicking nature's processes. So like materials in natures are continuously circulating in closed systems and in form of healthy and safe metabolism. The product manufacturing and then distribution and then reuse recycle, which is associated with designing any product, is designed mimicking that process of uh, natural nutrient circulation. So that is what is cradle to cradle model is trying to follow. So there are two types of cycles which are there in cradle to cradle. So first is a biological cycle, and another is the technological cycle. So the biological cycle, it is relevant for the materials which are biodegradable. So materials that are naturally biodegrade, that they can be returned to the ecological system and then further reused or recycled to be used as a raw material for another product. So that is those materials follow the biological cycle of the cradle to cradle recycling method. And then there is the technology cycle. So things like metals, oil-based plastics, chemicals, and these are some other examples of materials which can be recycled and then used for producing uh, other products which are of the same or better quality in closed loop of material circulation. Uh, so this is another type of cradle to cradle material. In this, the material don't need to naturally biodegrade. They are recycled through mechanical and chemical processes, and that is why it falls under the technology cycle. This is a quick graphic which tells you the same. For example, this tells you about production of uh, products like clothes or other things which are made of natural fiber. So the raw material is gathered from plants, then which is then produced, which is converted into a product, which is then used by an end user. Then either through biodegradation or some other recycling process or some other decomposition process, the product is degraded and converted into natural nutrients or biological nutrients, which again is taken up by other plants. So it can be the same plants or different plants also, but you get the point of nutrient circulation, that the raw material for the product came from plants and the end product of uh, uh, the end product, which is the biological nutrient which came from the product, is again then being consumed by plants. So this is the biological cycle for consumption of products, and this is the technical cycle. So technical nutrients are acquired from mining, through mining or other material processes for production. Then a product is produced, which is then used by the end user, and then it is taken for recycling. The uh, disassembly process for the product occurs, and then it is further broken down into technical nutrients through the product of through the process of recycling, and then this recycled material from the earlier product is then further taken for production and is converted into different products. So biological cycle can be used for consumables like natural fibers, cleaning agents, or other biodegradable packaging, which can circulate natural cycle. Um, Okay, and they turn into compost or other material which are then absorbed by plants, or and even in some cases the end product can be used to make new products also. For example, in the case of uh, wood or even cardboard or paper, which is often recycled to make new products. And technical cycle includes consumer goods like which circulate in the technical cycle. These are optimized during the design process only, so that they can be easily recycled and disassembled later during the recycling stage, and it can be sorted according to their constituent material, and then it is then recycled and then reintroduced in for in the technical cycle. So then it's again sent to the production, to the place of production where the material can be used to create the product. So I hope this is clear. Coming back, okay. So this you saw, this again follows the life cycle assessment system. So material formulation, or getting the raw material, then component production, production assembly, sales, and consumption and collection. So you can see in terms of the technical cycle, uh, the product can go back. So after the end of consumption, it can go back to sales and service. So this will happen when the product is still in a usable condition, but it's not required by the end user anymore. So it can again go to sales and service or redistribution. So it can be sold to another person who wants to use it, or it can be made available for other people to use. So in terms of service and distribution, things like that. Or it can go to product assembly. So reuse and repair can come under this. So for example, a product, some part of a product is not usable anymore, so it can then go back to the product assembly stage, where it can be repaired and made available to be reused by either the same end user, or even for another end user. Or then the product can even go to component production, where parts of components of the product, or parts of the product, so the end product is not usable as a whole, but parts of it are still in a usable condition, so they can be extracted from the product, and the components can be then used to refurbish another product. So in that way, in refurbishing or remanufacturing, the loop can be completed. Or the product can go for recycling or upcycling, and it can be broken down into its material components or the raw materials, and then the raw materials then further can be used to create a totally new product. So these are the different ways in which the technical cycle or of cradle to cradle works. And the biological cycle, you can see end product, either it can be regenerated by industrial processes to create uh, a raw material which can create a new product, or it can be regenerated through the natural environment. So either industrial processes or through natural environment, it can be regenerated and converted into a new raw material which can be then used for creating a new product. So coming back to the choices which were mentioned in the question, so we were given steel, paper, wood, and plastic. So now let us see which is the best uh, material which fits this cradle to cradle model. So paper is, of course, as I mentioned, it is recycled, uh, and it is recyclable and can be used uh, reused several times, but paper can only be used, recycled and only be used 5 to 7 times. This occurs because the fibers of the paper, it gets broken down the more times it is recycled. And paper like magazine, newspaper, and office paper, these papers are something which can be easily recycled, but the papers which absorb a lot of residue like paper towel and napkin, which absorb residue like food waste or oil, dirt, etc. These cannot be easily recycled because of presence of the foreign material in them. So paper is okay, paper is recyclable, but we cannot say that it is the best material which fits this cradle to cradle model. Then wood. Wood is again, wood fibers also get shorter with each recycling process. Thus, the new material or new product which we'll create with recycled wood, it will we will compromise the strength of the end product if we use recycled material instead of using new material. So wood also fits this cradle to cradle uh, cradle to cradle method, but again it has its shortcomings. Then coming back to plastics, in the previous week session, we studied that not all plastics are easily recyclable, although some plastics are. So plastics like PET and HDPE, these are the most recyclable ones, and they can be recycled several times. So they fit this, but they also have to be segregated from in different materials from their product. So because all different plastics have different compound structures, they cannot all be recycled together, and they have to be segregated before being recycled. And thorough sorting and cleaning needs to be done for plastic materials also, if we want to properly recycle them. Similar to paper, if they have a lot of foreign material, or if they are not clean, the recycling is not very easy or not successful. And also, even in plastic material, the strength of the plastic, it deteriorates over the time if the plastic is recycled again and again. So although plastic also fits this cradle to cradle model, again plastic is not the perfect material for recycling several times. The last one is steel. So steel is the most recycled material by weight. It is continuously recycled because of its chemical composition. So it is composed of iron and carbon together, and because of its properties, it retains its strength even if it is recycled multiple times. So it is favored as a recycling material because of its strength and its longevity, and ease of recycling also. So steel is the one which is suitable for this cradle to cradle model, and it can be recycled over and over without compromising the strength or the quality of the material. So I hope this question is clear to you, and it is clear that steel is the product which is the best example to fit the cradle to cradle recycling of material. I hope it's clear. We'll now move on to the next question. Before that, I've also shown the life cycle of steel here. So you can see in steel production, right during the manufacturing process, even in the manufacturing process, if any steel scrap is there or any material that is being discarded, it can go, it is 100% recyclable, and it can go back to the raw material processing state, and the raw material or the raw steel which is obtained from this scrap then can go further into use for manufacturing again. Even after use, steel is easily can be easily put through reuse and remanufacturing processes. And then even at the end of the life cycle of a product which has steel, it is the steel scrap from the material is 100% recyclable, and then it can go to the raw material processing factories, and then the recycled steel from there can go directly into the manufacturing of new product. If you want to read further about the life cycle of steel and why it is a perfect product to fit the cradle to cradle model, you can click onto this link which I have provided. It will take you to this website which tells you more about life cycle thinking in terms of steel manufacturing, how it is done, and there are several other links related to uh, different aspects of steel's life cycle analysis. So you can go further and read more if you want. I have provided the link here. You can just click on to this and read it in your own time. Okay, moving on to the next question. So next question is, as per the World Resource Institute, which of the following belongs or can be achieved in an existing building? And your options are design, retrofit, land use planning, and none of the above. So this refers to uh, building efficiency acceleration in terms of how you can make buildings more efficient. So this is a seminal publication by the World Resources Institute. So I've added the link to the publication here for you. So if I shared this publication with you earlier also. This is very good publication if you want to learn more about building efficiency, and I think we learned about energy efficient buildings, and at that time we referred this document. And again, for life cycle assessment also you can refer this document, as it has uh, key key graphics and processes uh, that have been shared for you. We'll come back to the question. So what the question is asking is in terms of life cycle of a building. So building, it starts with land use planning. Any building process or building construction process it first starts with land use planning. So the land use is decided, the way in which the plots will be divided, the roads will be laid out, different infrastructure and services will be laid out. Everything is decided, and that way roads or land parcels are planned. Then those on those land parcels, how the building will be constructed, how it will be how it will be designed. All the design process takes place. After the design is completed, then the construction of the building takes place, which is then sold to the end user or given on lease, then to a tenant. So then even the end user or tenant can have some building or some additional building or other processes related to the building. Then it is used by the tenant or the resident, and operation and maintenance of the building is done. Then either when that tenant moves out, or that tenant resells the building to someone else, or it's lent out to a different tenant. Some retrofitting can be done, or it can be done by the same user as well. So again, it will go to the through the process of operation and maintenance and use, and at the end of that use, when the building is not usable anymore, it will be demolished or deconstructed, and then a new land use planning for that land parcel can occur. So this is the whole life cycle process of a building. So what this question is asking, what processes can be done, or what can be done for an existing building. So you can see land use planning, design and construction. These three are associated with new buildings, or till the time a building has not been constructed. So design and land use planning are not the options for existing building. You can see retrofitting is one option which is associated with uh, existing building. So retrofitting actually is the process of adding new technology or new features to older system, and in this case our system is the building. So retrofitting in the building can be, maybe if you want to increase the energy efficiency, you can retrofit the building with new electrical features or new energy systems. So that is one example of retrofitting. So if you want to increase the efficiency of the building, which is of a building which is already existing, you don't have the option to land use plan or design or construct a new thing, but you can definitely retrofit new features or new technology into the existing building. So I think this is clear. Retrofit or retrofitting is the correct answer for this question. Please refer to this publication by WRI if you have further questions about the life cycle of the building. This is a very good publication, and I've linked it for you here if you want to study it in your own time. We'll move on to the next question. So the next question is, which of the following falls under the category of end of life for the LCA of a construction project? Then you are given four options: maintenance, manufacturing, recycling, and distribution. So for any construction project, there are four different stages, as we saw in the WRI publication also. First is the product stage, where raw material is extracted. Then is the construction stage. So using the raw material, uh, the construction of the building is done. And then use stage, where the building is used, it's maintained, repaired, refurbished, everything. And then is the end of life of the building, where it's demolished or deconstructed and waste processing and disposal takes place. So product stage, you can see A1 to A3 is the product stage. A1 is raw material extraction. A2 is the transportation of the raw material. So from the place of extraction to the site where the raw material is needed, and then manufacturing, using that raw material, manufacturing the components which are required for construction. So, for example, manufacturing of bricks or cement or other composite concrete materials or precast materials, things like that. So, that is the product stage. Then comes the construction stage. So, using all these material, uh, uh, first this material is transported to the construction site, and then it is installed or assembled in the construction process. Then is the use stage. So it is used by the end product. It is maintained over its lifetime. There may be repairs, there may be replacement of some components, and there may be refurbishment of some parts of the building. And then comes at the end of the building life cycle comes the deconstruction and demolition, and then transport of the waste. Transport of the waste, and then at the end disposal. So what the question is asking, which of these fall in the end of the life stage? So you can see end of the life involves deconstruction, demolition, transport, waste processing, and disposal. And our options here are maintenance, manufacturing, recycling, and distribution. You can see clearly manufacturing is part of the product stage. It's not part of the end of life. Same maintenance is the part of use stage. It is not a part of the end of life. And then distribution. So distribution comes under product stage again. So distribution may be related to transportation to the manufacturing site, or in the construction stage, transportation to the construction site. So that is distribution, but it does not come under end of life stage. So the only thing which comes under end of life is recycling, which is part of waste processing. So I hope this is clear to you, which is the correct answer. So because recycling is part of waste processing, which is a part of end of life stage uh, processes in life cycle assessment of construction project. That is the correct answer of this question. I hope this is clear. We'll move on to the next question. So the next question is, as per World Auto Steel life cycle assessment based life cycle assessment based vehicle emissions regulatory focus, which is the current focus globally in terms of vehicle emissions regulatory. So it talks about global focus, which is there on which part of the life cycle of vehicle-based emissions. So there is fuel cycle, there is raw material extraction phase, there is vehicle manufacture phase, and then emissions related to fuel and energy use. So you can see this is the life cycle assessment for vehicle use or any vehicle. So you can see here, first is the raw material extraction, which is then used to manufacture materials and powertrains and other components of the vehicle. Then these components are taken to manufacture the vehicle. The vehicle is manufactured, and then the fuel cycle related to the vehicle starts. So vehicle consumes a lot of fuel, and then the fuel is converted into energy for the vehicle, and then a lot of emissions are released into the atmosphere due to the use of the fuel. And then fuel energy use or tailpipe emissions. So this is the same cycle. And then at the end of the vehicle's life cycle, it is then recycled for scrap material from the vehicle. So this is the life cycle of the vehicle, and these are the different stages which have been mentioned in the question as different options. So this is asking what the global focus is on which part of the life cycle of the vehicle when it comes to uh, uh, global greenhouse gas emission. So you can see uh, fuel production and vehicle fuel usage releases the most amount of or most percentage of greenhouse gases in the whole vehicle's life cycle. So naturally, the focus of all the regulatory processes in curbing the greenhouse gas emission from a vehicle is on that only. So this part of vehicle's life cycle can be and is termed as the tailpipe or use phase emission. So almost all current legislation which is globally present for curbing greenhouse gas emission related to vehicles, it focuses solely on the combustion of the fuel or the emissions which are caused due to the consumption of the fuel or during the use phase of the product. So it is both for the fuel production as well as the consumption by the vehicle. So you can see there are still a significant amount of GHG production during the vehicle production stage also, but because the focus is on the tailpipe emission or the use phase emission, these this chunk of the GHG emission, it gets sidetracked while the regulatory policies are drafted for curbing greenhouse gas emission. So, for example, increasing fuel economy, it reduces tailpipe emission, but then it forces the company to uh, generate engineering solution which include more efficient powertrain and better aerodynamics and lightweight cars and lightweight vehicles, so that vehicle uh, so fuel use or the amount of fuel which is used by per vehicle is can be reduced. So correspondingly, automobile industry is under significant pressure to meet GHG emissions in different countries, but they focus on creating lightweight materials for their products and focus largely on the aerodynamics and the vehicle material. But what happens is that while they focus on lightweight materials only, the adapting of vehicles to lightweight materials and using different technology and different materials which are lightweight and things, they the processes which are involved in creating such materials and such designs, they are also greenhouse gas intensive. So although they are cutting down on the emissions in the fuel use, emissions in the vehicle production stage is increasing because creating lightweight materials and aerodynamic designs and the other things, they are creating more greenhouse gas emissions in the production stage. So although emission in this stage is being focused on by the companies and the regulatory body, so this here uh, emission is being reduced, but emission is increasing here. So this is what this question tries to pull your attention towards, that it is okay to reduce emission in one stage, but if you want to focus on reducing overall emissions related to any product, you have to focus on the overall life cycle of the product, not just one stage. So I think it is clear to us where the focus lies right now and how it needs to change. So in the given options, you have fuel cycle, raw material extraction, vehicle manufacture, and fuel and energy use. So we saw it very clearly that fuel and energy use is where the current focus globally lies on in terms of vehicle emissions. However, we need more focus on other phases of life cycle of vehicles also. For example, the vehicle manufacturing phase. So I hope this question is clear to you. We'll move on to the next question. So next question is, which of the following is not a step of life cycle assessment to assess environmental impact? We have in 4 options: inventory analysis, that is data distribution, impact assessment, goal and scope definition, and interpretation. So which of the following is not a step of environmental impact assessment related to life cycle analysis? So you see, these are the 4 steps which have been mentioned. So first is goal and scope definition. Second is inventory analysis, which is data collection. While you see the option here is given here is data distribution. Although inventory analysis is not data distribution, but collection of all the data which is required for impact assessment of uh, throughout the life cycle of a product. Uh, then is impact assessment, then it's interpretation. I'll just quickly tell you what all of these different stages means so that you have a general idea of different steps of life cycle assessment. Uh, so first is goal and scope definition. So this means the functional unit of any system, its boundary and its limits for the analysis are set in and they're outlined in the life cycle study. And this is where the life cycle study begins, as you start to identify the processes within the technical system which are going to be assessed in the whole life cycle assessment. Then is the inventory analysis, or the data collection part. So in which this all the system inputs and outputs, as we discussed earlier, in that there is a system, then there are things which go in as an input, and then there are emissions or effluents which come as an output. All of that is assessed, all the data is collected for all the inputs and outputs, and they are measured and recorded to form a functional unit of the life cycle assessment. So by end of this stage, you have an inventorized list which details out all the input and output which is going into a system. So this is what inventory analysis is. So this is data collection, not data distribution. So I hope it makes it clear to you how that option in the question is wrong. Next is impact assessment. So now, as we saw here, by creating an inventory, you have all the input and you have all the output. So using all the input, you can see by taking all the input from the natural environment what impact you're creating on the environment. So environmental impact assessment, because you're taking some input and then you are creating some output from the life cycle. So you are releasing some effluents, some emissions, and some waste products into the environment. So you can see from the output what different environmental impacts you will have. So you have inventorized list of all the inputs and all the outputs from any product cycle. So that way, uh, after the inventory, you go on to the impact assessment. So you see impact from all the inputs and you see impact from all the output of that whole product cycle, and you can conduct an environmental impact analysis based on that. And then after that comes the interpretation stage. So you have the impact assessment, you have the inventory, you have the everything, and from that you can interpret the result based on your earlier defined scope and goals, that what is most important for your product creation, how you can reduce the impact. So during goal definition and scope definition, you would have either had that you want to create a product which is green, which is sustainable, or such things. So at end of your impact assessment, you can see what steps you can take so that your product is sustainable. It is if you want, you can maybe, yeah, in your goal is there that you want to create a biodegradable product which will degrade on its own, or you want to create a compostable product. So from the impact assessment, you can then interpret the results from your impact assessment, how you can create the end product which you want. So these are the different steps which are in life cycle assessment, and uh, which part of life cycle assessment which are used to assess environmental impact of a product. So as you can see, option 1 is not a step, because inventory analysis actually means data collection and not data distribution. So I hope this is very clear to you, uh, how this question is to be solved. We'll move on to the next question. So this is a set of two questions which are related to the same phenomena. This talks about life cycle assessment for carpet material flow. Uh, so you would have seen this diagram during your lectures, which talks about carpet material flow, and it is taken from an annual report of carpet material flow, and it talks about how much material ends up in a landfill and how much is uh, how much of it is used, how much is goes through recycling processes, how much ends up in landfill through cutting losses or incineration, or at the end of its life cycle. So the first question asks that what percentage of used carpets ends up in landfills, and the options you are given are 80%, 83%, 75%, or 85%. So you can see 99% of the material uh, which goes into production of carpet material is virgin material input. That means that it is not recycled, it comes directly from nature. So 99% of the material or the raw material which is used in manufacturing of carpet, it comes directly from nature. Then it goes into manufacturing process, so make, and then to use. So uh, in the use in the manufacturing process, there are a lot of cutting losses. So 5% of the material is amounted to cutting losses in the manufacturing process, and this material from the cutting losses, because it is not being used, it goes directly to the landfills. Then after the manufacturing, the product is reused, and then 85% of the product at the end of its life cycle, it goes to landfill. 5.2% is incinerated or burnt at the end of its life cycle, and only 0.4% is reused. So only 0.4% of the product is reused from one user. It's transferred on to the another user for reuse. Uh, 4.4% of this carpet material is collected for recycling. However, 3.7 is again lost to recycling losses. Uh, okay. 4.4% is collected for recycling, but 3.7% of that is lost to recycling losses, and it ends up in the landfill. And then 0.7% is then finally recycled and then goes back uh, to the manufacturing stage, where this recycled material is then used for creating new product. So this is what is there. So this question asks what percentage of used carpets end up in landfill. So you see, used uh, carpet only 85% ends up in landfill. So it's not used which is incinerated, or used which goes into recycling and then ends up in landfill. It's the product that is used and ends up in landfill. So that the correct answer will be 85%. So this is your answer to this question. 85% of the carpet material flow, it ends up into landfill after its use. Next question is what percentage of virgin material input uh, in the above question is given. So this is talking about the material or virgin material input which is there in the manufacturing of carpet. So you can see from here 99% of the material input which goes into the manufacturing comes as virgin material and not as recycling. So I hope answer to this question is also clear that 99% of the material input is virgin material input which goes into the manufacturing of carpet. I hope that is clear. So that those are all questions for today's session. I saw that you were given a subjective type question in which you were asked to make a life cycle assessment chart or life cycle assessment chart for any household item. So I'll just refer back to these diagrams, which were, I think, discussed in the lectures as well. That how a life cycle diagram of any product can be made. So you have a product which you will see in this stage, so in the use stage. So you have to think both forward and backwards while you make the life cycle assessment chart. So you have to see first of all that where the material came from. So your product must have been manufactured in a place or in a manufacturing facility. So for example, this is life cycle assessment for a vehicle or a car. So it was manufactured in a factory where cars are manufactured, and the fuel it used, that is manufactured in a in a so I don't know. I think this is I don't know what this is referring to, but from the graphic, I can guess that it refers to an electric vehicle. So the fuel is being manufactured either from wind power or solar power, and then it's being converted into electricity, which is being used in the electric vehicle. So that is where the fuel is coming from. So similarly, you can assess if your product, or for whatever you are doing the assessment, where if it uses some kind of fuel, where the fuel comes from, that also you can include in your life cycle assessment. And then you can even think if there are ways in which your product can be reused or it can go into remanufacturing cycle, and then you can add it here also. And then you can think of the individual components of your product. So for example, in terms of car might have some metal parts, some rubber parts, some other different components. So you can figure out uh, from there what different components are there in your car, and from where the raw material of each component comes from. And you can then see how that raw material is extracted, and you can write that in detail. And after that, you can then think of how the different materials of the car are either recycled, or the waste at the end of product life cycle of your car is then uh, processed. So maybe the metal scraps of your car is recycled and used, and then sent again for use in manufacturing of other products, or similarly other parts as well. So that also you can detail out in your life cycle assessment. Similarly, this also was discussed in the lecture. So this is wool's life cycle assessment. So starting from the production, wool begins from sheep's. So the production process begins from the sheep pastures itself. So from there, wool is harvested from the sheep's body, and then it's uh, transported to processing station where it's processed. So it then consumes different chemicals, different other chemical or mechanical processes like washing and uh, converting it into threads and such. And then after converting into threads or other fibers, it's then distributed for production, either production or end use by customers. Then some kind of fabric or material is or product is created from that material, and either it's used by the end user and then goes to recycling to end of life. So this is the wool's life cycle assessment. So similarly, you can do life cycle assessment for some product in your household item, and you can present a life cycle analysis for that. If you want further help or you want to read further about life cycle assessments or how to involve life cycle thinking in day-to-day activities or to think about day-to-day products, you can visit this link. This I shared earlier also. This is UNEP's life cycle initiative. So you can visit here. This tells you what life cycle thinking is, and it also gives you several tools which have been developed by the UNEP for doing life cycle assessment for different products. So there are different reports also which they have prepared. They have training materials, articles, and expert reports also, which you can refer to, and if you want, you can use for your analysis, or if not only for this assignment, but even if you want to do life cycle analysis for another project or another thesis or your thesis or other research projects also, you can refer these. So for example, carbon footprinting, how that is done, then how to create LCA databases, things like that are there. So decision making support for life cycle assessment, so it can be relevant when you're studying different policies or regulatory arrangements which are there for life cycle assessment or recycle or waste disposal, things like that. These can be really helpful. So if you want, you can refer to the reports and training materials and articles, expert reports, things like that on this website. Also, uh, in the tools, you can see here there are different general life cycle knowledge and tools. So for example, you can even say examples of different business cases. So here you can see they have a publication also in which you can read how the business case for life cycle thinking or how the life cycle is involved in business models by different businesses. For example, this is for some cafe. This is from, I think this is for coffee production. So how life cycle initiative is involved or it is incorporated into coffee production. Then how uh, it is used for fruit or in terms of food waste and other things like that. You can go ahead and read in detail on this website. So I hope this is helpful to you. Please feel free to access all these extra resources and take advantage for your assignments or any other further study if you want to. That is all that I want to discuss today. If you have any questions, please go ahead and please go ahead and ask that in the chat box. You can just write in the chat box and ask all the questions which you want. Kirti has no questions. I see Anand and Sagar also. Anand and there is Sagar S and Sagar Sinha. If you want, please go ahead and ask any questions if you have any questions. Anand and Sagar, do you have any questions? Okay, I think there are no further questions. So I'll end the session for today. Thank you everyone for attending today's session. I hope it was helpful to you. If you still have any further questions which you might get after the session has ended, please feel free to post them on the forum. We'll be happy to answer your questions on the forum also. Uh, all the lectures and all not the lectures, all the live sessions are being recorded for if you want to access them later, they will be available on YouTube. So a link for the YouTube videos where the sessions are uploaded, that will be shared with you after the session is ended. Please feel free to go through the videos and all the materials. Even the materials which I'm presenting here, it will be shared with you. There you must have a link for a shared drive folder where all this material is uploaded. So all this material and all the associated links which I have put in the material, it will be made available to you, and you can go and access them in your own time. If you have any questions, please feel free to ask. You can even ask the question in next session which we have. So please feel free to ask if you have any doubts. I'll close the session for today as no one has any further doubts. Thank you everyone for attending today's session, and I'll see you in the next one. Goodbye.